Okay, so we're going to try this 13.5 one more time. Our essential question is, how can you solve a triangle that is not a right triangle? Our old method of solving, we always had to solve right triangles, use the Pythagorean theorem, trig functions, or inverse trig functions. Remembering that trig functions are used to find side lengths and inverse trig functions are used to find angles. What we're learning new today is solving non-right triangles. The tools that we're going to use to solve these is the law of sines and inverse trig functions. Okay, so you can see that the law of sines is written here. It's the sine of angle A over side length A equals the sine of angle B over side length B equals the sine of angle C over side length C. Knowing that we can also turn these fractions upside down and set them equal as well. And the law of sines can be used to solve angle side angle and angle angle side and side side angle. Now angle side angle and angle angle side you should remember from geometry, and they are congruence conditions, so we can use them to prove there's exactly one triangle with those lengths. Okay, so for these two examples there's only going to be one triangle. If you remember back to geometry, there are no SS angle congruence conditions, so this can produce several different options. You can have 0 triangles, 1 triangle, or 2 triangles, and depending on if you're given an obtuse angle or given an acute angle, different things can happen. So we're going to go over several examples here. The first one happens to be an angle angle side. And the first thing we're going to do is right off the bat draw a picture and label our stuff, which I've done already. And what I'm going to do is actually solve for that first angle. Okay. So I'm going to take 180 degrees and I'm going to subtract the two angles that I have, 107 and 25 degrees. And what I'm going to get is 48 degrees. And I'm just going to plop that into my triangle. Okay. The next thing that I'm going to do is solve for a side length. So I'm going to look, and I tend to like to do those in alphabetical order, so I'm going to solve for this side length right here. So I'm going to take the sine of angle A, which is 48, over side A, and set that equal to the sine of 25 over 15, because now I have to have both the top and the bottom of my next proportion. When I cross multiply, I get A times the sine of 25 is equal to 15 times the sine of 48. I divide by the sine of 25 to solve, and I get A is equal to 26.4. The only other thing I have to solve for now is C. So I'm going to take the sine of C, well, that's 107, and put it over side length C, and I'm going to make my other side the same, the sine of 25 over 15. When I solve that, I get 15 times the sine of 107 is equal to C times the sine of 25. I just have to divide by the sine of 25, and I end up getting C is equal to 33.94. And my triangle is solved. Going to my next example, you see that this is also an angle angle side, so we're going to skip this example and go right over to the side side angles. So we're given an obtuse angle and A is less than B. Okay, this produces no possible triangle, and the reason why is the longest side has to be opposite the largest angle. If we're given an obtuse angle, we know that is the largest angle in the triangle, and 6 is not the largest side because 8 happens to be bigger. Okay, so an obtuse angle where A is less than B gives you no possible triangle. If you're given an obtuse angle and A is greater than B, there's exactly one triangle. So we're going to solve for that one right now. Now notice we're given two sides and one angle. So I have to solve for an angle, and it's going to be angle B. So I'm going to do the sine of B over 11 is equal to the sine of 115 over 20. When I cross multiply, I get 20 times the sine of b is equal to 11 times the sine of 115. To solve this, I have to divide both sides by 20, and I get the sine of b is equal to 11 sine of 115 over 20. I have to do the inverse sine to find b, and when I do that, I get 29.9 degrees. Okay, so this is 29.9 degrees. I can find the third angle by taking 180 degrees, minusing 115, and minusing the angle I just found of 29.9. And what I get is 35.1 degrees. Now there's only one side left, so I'm going to take the sine of 35.1 over side C, and I'm going to set that equal to the sine of 115 degrees over 20. When I cross multiply, I get 20 times the sine of 35.1 is equal to C times the sine of 115. When I divide by the sine of 115, I'm going to get my answer, and C is equal to 12.7. My answers seem reasonable because my 35.1 is just a little bit bigger than 29.9, and my side length is just a little bit bigger than the corresponding side length. Okay, we are now going to go on to our next examples. Oh, how about we try this example right here? If I am given an angle of 51 degrees and a side length A of 3.5 and a side length B of 5, now I'm given an acute angle and an A that's smaller than my B. I'm going to actually find this height here. So if I draw in this height and label it x, that height could be the sine of 51 is equal to the opposite over the hypotenuse. I'm going to multiply both sides by 5, and I'm going to plug this into my calculator, and what I'm going to get is 3.9. Now, would it be possible for this to be 3.9 if this was only 3.5? What's going to happen is that this is not going to connect here if I actually drew it to proportion. Okay? This side A has to be bigger than the height because this is a right triangle and this would be the hypotenuse, which would be the longest side. So this produces a no triangle situation where A is less than B and it's less than the height. Okay? So moving on to our other examples. We have 2 more to do. It looks like you're given an acute angle and we get one triangle, and what this looks like is that A is going to be bigger than B. So again, I drew a triangle. Keep in mind A is bigger than B here. And what I need to do is I need to find an angle. So I'm going to do the sine of B over 2 is equal to the sine of 33 over 27. When I cross multiply, I get 2 times the sine of 33 is equal to 27 times the sine of B. When I divide by 27, I get the sine of B is equal to 2 times the sine of 33 over 27, and I need to do the inverse sine to figure out this angle. And when I do the inverse sine, I get 2.3 degrees. That seems like a very small angle, but notice this is a very small side as well. I'm going to find my third angle by taking 180 degrees and minusing the 2 angles that I already have. And I get 144.7 degrees. Okay, now notice I was given an acute angle, but that doesn't mean it's an acute triangle. This is an obtuse triangle, and my triangle is not drawn to scale, but that's okay. Now I only have one thing left to find, and it's this side. So I'm going to take the sine of 144.7 and put that over the side length C is equal to the sine of 33 over 27. When I cross multiply, I get 27 times the sine of 144.7 is equal to C times the sine of 33, and I divide both sides by the sine of 33, and I get C is equal to 28.6. Moving on to our final example, we have an acute angle and two sides where A is smaller than B. So I'm going to first try to find B. So I have the sine of B over 25 is equal to the sine of 38 over 19. And I cross multiply, and I get 19 times the sine of B is 25 times the sine of 38. I divide both sides by 19. And again, I get the sine of B is 25 times the sine of 38 over 19. And I do inverse sine to find my angle B. It's 54 degrees. Okay? But I know if I look at 54 degrees, it's in the first quadrant, and I know that the sine is also positive in the second quadrant, so I can get another angle, which is 126, where I get the same value. This is what produces two triangles. So I need a triangle, and we're going to put a second triangle over here. It's going to be obtuse. We're going to have this angle A still 38 degrees, and this angle B is going to be 126 degrees. And here we're going to make angle 54 degrees. Okay? So we'll completely solve this first triangle, and then we'll go and solve the second triangle. So to find angle C, I'm going to take 180 degrees minus the two angles I have, and I am going to get 88 degrees. Okay? And then I need to find the missing side, so I'm going to take the sine of 88 over C is equal to the sine of 38 over 19. I'm going to cross multiply to get 19 times the sine of 88 is equal to C times the sine of 38. What I need to do is I need to divide by the sine of 38, and I get C is equal to 30.8. Now my first triangle is solved, so I have to do the same thing with my second triangle. So I'm going to find angle C by taking 180 minus 126 minus 38, and I'm going to get 16 degrees. So this angle up here is 16 degrees. I am now going to find my missing side. So again, I'm just finding the sine of 16 over C. C is the only side we don't know. And I'm setting that equal to the sine of 38 over 19. So I get C times the sine of 38 is equal to 19 times the sine of 16. I divide by the sine of 38. And I get C is equal to 8.5. So here you can see that there are two triangles for this case. Thank you, and check my webpage for the homework.